Welcome. This is Dr. Sudha, Associate Professor, Department of Mathematics, Drupatunga University. In this session, let us recapitulate some definitions, simple groups, solvable groups, problems on simple unsolvable groups will be discussed. So let us recapitulate the definition of a simple group. A group is said to be simple if it has no non-trivial normal subgroups. So what does that mean? A group G is said to be simple if its only normal subgroups are the trivial normal subgroups, that is E and G. So if G has any other normal subgroup other than E and G, then it is said to be not simple. Definition of solvable group. A group G is said to be solvable if there exists a series of subgroups of G such that G contains N0, contains N1, contains N2, likewise contains Nr, where it is equal to the identity element E alone, such that Ni is normal in Ni minus 1 and Ni minus 1 by Ni is abelian. That is, if I take this series of subgroups, here N0 must be normal in G. N1 must be normal in N0. N2 must be normal in N1. Similarly, E will be normal in Nr minus 1. Right. Apart from that, G by N0 must be abelian. N0 by N1 must be abelian. N1 by N2 must be abelian. So likewise, all the quotient groups here must be abelian in this series. Such a series of subgroups are called solvable series for the group G. Hope everybody followed this. Now let us consider a few examples. Let us consider S3, the symmetric group of degree 3. So what is order of S3? It is 3 factorial and that will be equal to 6. Now we know that A3, the alternating group of degree 3, which is a subgroup of S3 and it contains all even permutations of 3 elements. So A3 is a subgroup of S3. Now let us see what is order of A3. Order of A3, we know that it is order of S3 divided by 2. So that is 3 factorial by 2. That gives us 3. And 3 is a prime number, right? Therefore, since it is a prime number, A3 will be abelian. And if I want to calculate order of S3 by A3, it is order of S3 divided by order of A3. That is index of A3 in S3. So it is 3 factorial by 3. So you get 2. And 2 is also a prime number. Therefore, this S3 by A3 will be abelian. Apart from that, index of A3 in S3 is 2. Right? Since we have studied in groups that index of a subgroup in a group is 2, then that subgroup will be a normal subgroup of the group. Therefore, A3 is normal in S3. A3 is normal in S3 and we know that A3 is not equal to S3. Also, A3 is not equal to the element containing only the set containing only the identity element I. Therefore, you have I contained in A3 and A3 contained in S3. Therefore, S3 contains a non-trivial normal subgroup A3. Since it contains a non-trivial normal subgroup, S3 is not simple. Also, if you take this series, so each one of them are normal in the other. Therefore, I is normal in A3, A3 is normal in S3. Now, if we take the quotient group that is A3 by I, it is nothing but A3, and we know that it is abelian because its order was 3, a prime number. Also, S3 by A3 is also abelian since even its order was 2, a prime number. Therefore, you have a sequence or a series of subgroups of S3 like I contained in A3 contained in S3, and I is normal in A3 and A3 is normal in S3, as well as A3 by I is abelian, S3 by A3 is abelian. Therefore, S3 is solvable. Now let us move on to S4. It is a symmetric group of degree 4. This is solvable but not simple, right? So let us consider I contained in N contained in A4, and A4 contained in S4. A4 is the alternating group of degree 4, which contains all even permutations which belong to S4. And N is the set which we are taking here, that is I 1, 3, 2, 4. It is a product of two cycles. Okay. 1, 2, 3, 4. Once again, product of two cycles. And 1, 4, 3, 1, 4, 2, 3. It is also a product of two cycles. And this N, if you check it, it is abelian as well as it is normal in S4, right? So you have a non-trivial normal subgroup in S4, that is N. Therefore, S4 is not simple. Next, the alternating group of degree 4, that is A4, is contained in S4. And what is its order? That is order of S4 divided by 2, that is 4 factorial by 2, that is 24 by 2, which gives us 12, right? And I is normal in N. N will be normal in A4. A4 is normal in S4. E is the solvable series for S4, right? Next, N by I. It is abelian because order of N is 4 and 4 can be written as 2 square. Therefore, it is a prime power. Okay. Therefore, N is abelian. A4 by N is also abelian because order of A4 by N is 12 by 4, and that is 3, and 3 is a prime number. S4 by A4 is also abelian since order of S4 by A4, if you consider, it is 4 factorial by 12, and that is 24 by 12, which gives us 2, a prime number. Therefore, all these quotient groups are abelian, and apart from that, I is normal in N is normal in A4, and A4 is normal in S4. Therefore, S4 has a solvable series and hence it is solvable, right? Next, we can show that every abelian group is solvable. If you take any abelian group G, then E will be contained in G. And G by E is nothing but G is abelian. Therefore, you can take the solvable series E and G alone, and we can say that E is normal in G. This is true for all groups. Therefore, you have a solvable series E and G. Therefore, G is solvable.